All right, so next we're going to talk about observability with Lesley Cordero. Lesley, thank you so much for being our second speaker. All right, do you guys need help?
Cool. All right, I'll get started. So hello, everyone. Welcome to my talk on effective observability patterns and microservice architectures. So just a little bit of background on me. I'm a senior engineer at Teachers Pay Teachers. I've spent all of my career in edtech, so I've seen edtech grow and change many times. But I think I can speak for pretty much everyone in edtech when I say that we didn't expect the challenges that would come when the world decided to go online 2 years ago. So challenges I never thought I'd see in my career happened during remote learning times, going from 40 million to 100 million, over 100 million users on Google Classroom in the course of a month, migrating school districts the size of entire countries onto Google Workspace and Classroom, and all the production issues that came along to support that. Production issues that I never thought I'd have to face in my entire career happened during remote learning times. And no one was really fully prepared, right? And so as you might imagine, this gave me a really deep appreciation for the perils of debugging production. And so I took this experience with me when I moved on to TPT and focused a lot of my time on observability as a tech lead and engineer. And so this talk is a compilation of the learnings from the past couple of years, as well as my experience building data pipelines and developer platforms in the past. So I like to begin my talks by providing a shared definition of the topic I'm going to be talking on. So let's begin there. Now, as much as I hate repeating words on a slide, I'm going to do it if only for emphasis, so bear with me. Borrowing Liz Fong-Jones' definition of observability, observability is the ability to understand what's happening inside of your software systems to debug problems you've never seen before, just using telemetry emitted by your applications. She also goes on to say it's also not about a specific tool, it's about your team's ability to analyze that telemetry data. And so this is a loaded definition, but there's some important components here that I'd like to highlight. So the first is this part about being able to understand the internals of your software systems just using telemetry, which is data that represents the inputs and outputs of your system. You most commonly know these to be as metrics, traces, logs. And the reason for this is because the hardest and most interesting problems in software are the ones that you've never seen before, right? There were those problems I saw in the thick of the pandemic, issues I never thought I'd have to encounter. And it's incredibly hard to predict what specific issues you'll encounter, right? No one was going to predict that a pandemic was going to happen and that we'd have to suddenly scale from 40 to 130 million users, right? So it's better to actually equip your engineers with the right data, tools, and most importantly, knowledge. Which is why this last part of observability is what really distinguishes it. The most important part of observability and doing observability well is that your engineers understand how to use telemetry to figure out what and why something is happening inside of their application. And this can be hard enough for any application, right? But it becomes even more difficult as your apps grow in complexity, right? And complexity makes things so much harder, right? It makes building our applications harder, right? And it definitely makes debugging applications harder. And it makes it so much harder, right, that we as a collective industry, right, have changed and evolved the ways that we build applications, right? And so just like we've evolved the way we build applications to embrace microservice architectures, we must evolve the way that we debug applications to embrace this fuller definition of observability. And so if microservices are a solution to reducing development complexity for large applications, true observability is a solution to reducing the complexity of debugging these same large applications. So microservices and observability, right, they're both great solutions for navigating complexity, right? But there are some new organizational challenges that pose a risk to organizations that rush into implementing these. So first we begin with, and I'll go through 3 of them. First we begin through the first common challenge of silos and drift between different teams and organizations, despite the fact that we're operating in the same architecture. Right, so one of the organizational benefits of microservice architectures is the new autonomy that we get to experience, right? We love the flexibility of like being able to use our favorite tools and languages and build services in the way that we think is best. But there are, like everything, there are trade-offs to that, right? And first, right, the first is that we lose consistency that makes knowledge more transferable between teams. Right? And that lack of shared knowledge is what leads to those serious silos, and the lack of consistency is what causes this drift. And we see the same happen with observability, right? With the increasing number of tools out there, different instrumentation techniques, ways of structuring our logs, et cetera, we end up in a similar situation where context becomes super specific to the team or service that you're working on, right? And so the consequences of these silos, right, is that the teams end up doing a lot of duplicate work, right? Because we end up basically reinventing the wheel for what we consider our best practices. And this like basically gets to the core problem with decentralization. We lose the advantage of ensuring that our teams have a minimum bar of quality for how we're approaching our work. So secondly, we have sorry about that. Cool. Next, we have a challenge that engineers love to talk about, which is having multiple points of failure, right? Common challenge in microservice architectures, right? A lot of us have experienced the consequences of one microservice's failure becoming a point of failure for our own services that we own, right? We understand this risk, and we tend to plan for this risk. And the same, again, applies to observability, right? But in a slightly different form, and that's in the form of information gaps. So when we have an observability gap in our system, we risk not having the needed context to identify all the contributing causes of an issue, right? And that context might be essential for figuring out the next steps forward. And as we have more and more gaps, right, this risk increases. And if we aren't able to determine, what the next steps forward are because of these gaps, right, the failures that we see in production, right, can continue longer than they would have had we not had those gaps. So much like we need to think critically about how we plan for failure, we need to think critically about the observability gaps that might lead to prolonging the failures. I'm going to take a break for a minute. Cool. So talked so far about two organizational challenges. And really what each of these really lead to is that there's an inherent lack of certainty. Right? The autonomy that comes with decentralization means that coordination and collaboration efforts between teams are less necessary, which is great, but the danger with this trade-off, right, are the assumptions that we end up making in the process, specifically the assumptions we end up making about how other teams are approaching observability. And inevitably, right, these approaches will end up conflicting, and particularly when this happens frequently, right, we risk teams no longer really trusting each other to provide the context that we need when investigating an issue. And this is not an exciting state to be in. There are both technical and cultural consequences to allowing this to fester. So what I'll spend the rest of this talk talking about is like, how do we address these challenges while preserving the organizational benefits that we get from microservices like autonomy and clear boundaries of ownership? And the answer that I'll provide is basically by building a standardized observability platform. So this concept of platform thinking or becoming platform forward, right, has been, I think, particularly popular with microservices for the same reason that we'll, again, be talking about it today, which is that it helps drive standardization to address the challenges we just reviewed. And so what does a platform actually encompass? And I define it as having three major components: the patterns that guide us, the strategies that support us, and the stack or tools that we use. So at the highest level, right, we have the patterns that we use to make our systems observable and understandable, right? And in the context of a standardized observability platform, these patterns should serve this primary purpose by defining how we use standardization to address organizational challenges while maintaining those original benefits. And so the way that standardization does that in an observability platform is ultimately by standardizing the way we communicate, both in terms of how our services communicate with one another, but also how we enable our services to communicate with us, the engineers. And so going forward, I'll refer to this pattern as having a standard communication protocol. So let's get more specific as to what that protocol encompasses and how it addresses silos, drift, points of failures, and uncertainty. So there are three requirements that make up the standard communication protocol. First, we have the need for standard data specifications. So these specs should clarify the expectation of what our telemetry should look like to reduce any of the uncertainty that leads to silos and drift. And getting these data specs right is foundational, right? Because this is ultimately the telemetry that engineers will rely on to investigate and solve issues. So when this data isn't consistent, right, there lacks a level of predictability and reusable knowledge that makes analyzing that telemetry easier. So to make this more concrete, ground this in an example, let's talk through an example of where logs from 3 different services, but in the same application, have an inconsistent spec. Yep, so I'm sure many of you have encountered a similar issue here, right? So pretty immediately, right, we can see some differences here, right? In the first 2 logs, we have 2 JSON formats that have the same trace ID, but it wouldn't really be as easy to identify them as such because the key formats don't match, right? One is camel case, the other is snake case. And in this last case, right, the camel case trace ID matches the first log, but it's not even in the same format now, right? Like we have to go through the trouble of parsing this random string before ever being able to match it to the other traces. And that sort of data reformatting should never happen during an active investigation, right? That's friction that we can proactively solve by making correct and consistent formats a table stakes pattern for observability platforms. So next we have standard context sharing. So this context sharing, right, is governed by a set of rules for how context should be sent or propagated between services. And this is important, right, because the shared context is what ultimately allows us to connect or correlate related telemetry together. So for example, right, in our last example, having a way to easily retrieve all those logs we just saw through the universal trace ID. Cool. And that information that is shared essentially should be also in your shared data specs. But really what this provides us is a mechanism that services can use to comply with the standard. So again, to ground this into reality a little bit, let's build off our last log example. Again, 2 different services, but this time we formalized the way that we pass the trace ID by taking advantage of a protocol that we all love and are familiar with, right? HTTP. And because we can assume all of our services use HTTP, because maybe as an organization we've standardized the way that services communicate, we can standardize the way we pass context by always inserting the information into its headers. And lastly, we have well-defined services, or interfaces, sorry. These interfaces generally serve 3 use cases. The first is collecting telemetry data. For example, the tool that would collect the logs that we just saw. 2, processing that telemetry data. So these are usually separate interfaces that do things like reformatting and then exporting that to other interfaces. And then lastly, we have the interfaces that actually analyze that data. And these are more like end user, like engineering end user facing tools that we use to investigate. So think like Datadog, Honeycomb, et cetera. And these interfaces, again, should be well defined because it clarifies the expectations of how our systems are being observed. And so I do have a lot to say more on this point, but I'm going to leave it at this for now because we'll revisit this later when we talk about how these patterns manifest themselves in our observability stack. So before we go into the patterns, into how these patterns manifest into the tools we use to observe our systems, let's revisit our definition of observability. And I will also take the opportunity to take a sip of water. So earlier I said that what really distinguishes observability is this highlighted part, right? About how it's not really about your telemetry tools. It's more about your team's ability to understand that telemetry and analyze that telemetry. So far we've talked about the patterns that drive standardization, right? And in an easy, perfect world, right, like we would just set these standards, build tools that support these standards, use the tools, and just become like really awesome at debugging production, right? But I don't know about you all, it's never usually that simple, right? Every solution introduces its own unique set of problems, and in the case of introducing standardization in the way that we observe our platforms or our systems, we now have to start thinking about how we make our teams follow those standards, and more importantly, how do we make sure teams have the skills to use our platforms effectively? So to address these challenges, I define platform support as the second component of our platform. And that's because a platform without adoption or without support, or engineers without the skills to use that platform, right, might as well be a platform that doesn't exist. And so before I go into defining the strategies guiding that platform support, I want to just acknowledge, right, like building observable applications, right, requires investment, right? Investment in time, resources, et cetera. Because telemetry isn't just given to us for free, right? We have to think about observability as we're building applications instead of afterwards, which is a pattern I think I see way more often than I wish I did. And so it's mostly, when we're in the middle of an incident that we start to regret like not having invested that time. And so I think this tension is right why a lot of microservice organizations have come to embrace, again, this idea of having like separate platform teams and having a separate platform, right? And I think this organization pattern also aligns well with here. It does make the effort to drive that standardization easier, right? Like if you have a team that's actually dedicated to doing this work more full-time instead of having to coordinate, efforts across multiple teams or orgs. Right, and so right now, at my current job, I am on a platform engineering team driving these changes. But platform engineering teams, right, we're not saved from the social challenges of this work, right? Like instead of having to worry about coordination strategies, right, we have to worry more about effective support strategies. And so what do those support strategies look like? So I think first, the most effective strategy for enabling engineers to build observable systems is to make it easy, right? Pretty straightforward. But setting the standards that we reviewed earlier, right, is a huge step towards that goal, right? But we can also reuse patterns from developing production-ready microservices to further serve this goal, right? And I think a common microservice pattern that we see, right, is standardizing the ways that services are built so that it's easier to build production-ready services. And you see this most commonly through like org-wide templates or libraries, right? And we can apply the pattern here too, which is what we do at TPT. So we can take advantage, right, of whatever standards we set to actually implement the interfaces supporting these patterns in a way that makes them reusable and easy to integrate throughout the rest of your org. And the benefit of this, right, is like as we take on more implementation details that product teams would have otherwise, the more we can make sure that one, teams are actually following the standards, and two, we're also freeing up time that can be spent tackling problems that can't be automated or implemented away. And one of those harder problems, right, that can't be implemented or automated away, right, goes back to Liz's point about building our team's collective ability to analyze telemetry. And so since this is, again, one of the, I think, the most important parts of observability, right, the time that we save by consolidating efforts is super crucial, right? Because I think the biggest investment that organizations can make with respect to observability is providing engineers time to invest in their skill set. So defining, support, what support looks like can be super challenging. Arguably, a lot of times it's more challenging than the technical portions of this work. But I think the best thing I've ever done to support the teams I've led is standardize the way that we do like on-call training and what actual on-call looks like. I know a lot of us like hear onboarding and training and cringe, but it is hard to do well. But I think if you make it start to think of it as less of just an onboarding thing and more as an essential feature of how you do engineering, the more value you tend to get out of it. And the nice thing that aligns with this approach to observability, right, is that the advantages of standardization, right, is that the knowledge is easier to share more widely, right? Since, again, we're purposely building with the intention of shutting down silos. And lastly, I think the most effective long-term strategy to support observability is embedding observability into your culture. So fundamentally, this means constantly reinforcing the idea that observability is a crucial part of what it means to manage production services. The strategies we just talked through, right, they do lay some foundation for this by making it part of your engineering culture, but there are plenty of ways that we can do to reinforce this. So for those of us who are engineering leaders, like maybe a manager, a tech lead, or staff engineer, right, like we are in positions where we can take on the work of driving this work top down and bottom up. So for me, this has meant working with my engineering peers and cross-functional partners like product to get their buy-in that this work deserves prioritization. And so luckily for us, the industry has already thought about this actually, which is why I've spent a lot of my time at TPT also driving the adoption of SLOs or service level indicators. I'm not going to go into the details of this, what this work involved, because that could be its own separate talk. But the more important takeaway here, right, is that SLOs provide a clear decision framework for making it easier, that makes it easier to hold your culture accountable to your reliability needs. All right, so now that we've reviewed the platform and support patterns guiding our observability, we can start to talk about how they manifest themselves in the ways that we build our actual tools. And we'll refer to this toolkit as our observability stack. So what even is an observability stack, right? Like what's the purpose? And so put concretely, right, an observability stack is basically the collection of interfaces or tools that facilitate service-to-service and architecture to engineer telemetry communication. So if you remember the interface pattern from earlier, it introduced the idea that separate concerns should be handled by separate interfaces. And I briefly mentioned the use cases back then, but just to iterate them and put them into a larger context, let's review them again. So again, right, the goal here is to facilitate communication between our architecture and ourselves. Our architecture, right, uses the standardization communication patterns to generate telemetry that we mentioned earlier. And our tools, the end user-facing ones I mentioned, like Datadog or Honeycomb, right, receive all that telemetry so that we have access to it as needed. And so how do we go from generating our telemetry to actually receiving it? And the answer is, we need some layers of abstraction to facilitate this, right? And so I'll roughly refer to this as the communication layer of our observability stack. And just like anything, there are many design decisions you can make in terms of how you separate the interfaces to make up your communication layer. But I'm going to use my data eng background here and split it into 3 phases that roughly correspond to the Etl Data Pipeline. And for those of you who are unfamiliar with that acronym, ETL stands for Extract, Transform, Load. But in observability, we tend to refer to those as collect, process, and export instead. Cool. So just really going to run through what each of these components are, right? The first, right, is just it instruments our telemetry from our architecture, right? The second part just further processes the telemetry to comply with whatever data standards we have. And the third exports telemetry to use to your end user applications like Datadog or Honeycomb. So now that I've reviewed the different parts of our communication layer, we're going to shift our focus back to talk through the patterns that should apply throughout the pipeline. So first, let's talk about 2 important design principles that should guide our stack. The first is that our communication layer, right, should be reliable. Right? In addition to the actual data pipeline being reliable, reliability here also means that the telemetry itself also is also reliable. So that means in addition to like minimizing data loss and duplicate data, right, we want to make sure that our data is accurate or complete. And completeness should always be defined by our standards that we talked about earlier. And the next design principle we have is richness, which basically just expands the way that we think about telemetry to include an added flexibility that allows us to collect data specific to the service and environment that it's being emitted in. I kind of talked around this point earlier, but part of defining your specs for your telemetry is also defining how a service would emit service-specific data. Like what about your Kubernetes environment, for example. And the reason this is so important is because it's how we end up solving unknown unknowns, right? It's not always clear what data we may or may not be relevant during investigation. So we should generally try to bias towards collecting information that can't be found elsewhere or reasonably approximated. So that means generally embracing high dimensional or high cardinality data instead of being scared of it. So what do these design practices look like in what do these design principles look like in practice? I'll review 4 best practices that you can use to build a robust communication layer. So the first is a pattern that goes back to the first pattern we talked about, which essentially asks, like, what's our shared definition of telemetry, right? I posed this question and why asking and answering this question is important, but I didn't really provide like an opinionated answer outside of a vague reference to the fact that like traces, logs, and metrics are things that exist. And so what I'm about to say isn't anything that's super new, but it is important, which is that whatever shared definition it is that your organization comes up with should be driven by an event-oriented model of telemetry, where an event is one singular unit of work. And this is because being driven by events rather than being driven by traces or logs or metrics removes the limitations that we tend to place on ourselves as an industry by caring about one of these more than the other. In an event-oriented world, right, the best insights we get are from analyzing telemetry when we piece together these different ways of interpreting telemetry, right? So in other words, it becomes less about like a singular log or metric and more about like, here's a thing or an event that happened. How can I use my trace data, my logging data, and my metrics to figure out why, what, and how this event even came to be? And this is the flexibility that we, again, don't always usually give ourselves when thinking about observability, right? We tend to see traces, metrics, and logs as completely different things when they're not, right? They're really just different representations of the same information. So now that we have some more concrete definitions of telemetry oriented by events that we can fall back on throughout our pipeline, we want to refer back to our reliability and rich data principles that we mentioned before. And so what's our next step forward? It's instrumentation. And again, we see the influence of standardization pattern here from earlier, right? The biggest benefit of standardization is the certainty it gives us, right? And when we talk about our data needing to be reliable, what we really mean to say is that we want to be certain of what it looks like. And since instrumentation is ultimately what creates our telemetry, it's important that the way that we instrument our telemetry is consistent. That way we have a baseline understanding of how we can expect our events to look like. Which brings us to our next 2 best practices, which is that first, auto-instrumentation should be the first strategy for instrumenting your applications, since it's the best way to ensure consistency. Now, I also included manual instrumentation here as a 4th point because you will likely need instrumentation at some point, right? Either to annotate context specific to your architecture, but generally speaking, right, like that should be complementary to your auto instrumentation instead of a replacement. And so this wraps up the best practices portion of our communication layer. What we're left with now are the tools that we end up using to receive all this data so that engineers can actually analyze it. So when it comes to this part of our observability stack, right, most of us rely on external vendors for these tools. So for example, like at TBT, we use Datadog and Sumo Logic. And most of us aren't building our own homegrown tools, right? So instead of focusing on design patterns like I did in the last section, I'm going to focus on a few criteria that we can use to inform the way that we choose our tools. And so when it comes to choosing tools, both generally, but of course I'll focus on observability, I think of it as an exercise of like managing complexity again, right? We already have to learn so many tools as engineers, so we should always be purposeful about introducing a new one. And so what does this purposefulness look like? First and most obvious is like, what gap does it actually solve, right? We want to have access to the functionality that will enable us to debug, but we also want to be careful about introducing redundancy, both in terms of functionality, but also in terms of like introducing multiple data sources to reference, right? The consequences of the redundancy, right, are like, first, one, having multiple sources of data could have conflicting information. And 2, having multiple ways of doing the same thing can lead to diverging practices. And so this is the point of view that you should always be starting from when doing any tool evaluation. Secondly, right, how compatible is it with our architecture and our platform vision? Right, so how would it require us to take on more complexity by supporting new interfaces, or could we end up reusing some of the existing interfaces for collection, processing, and exporting? Like, do we have to introduce new interfaces, or and if we do have to introduce new interfaces, right? Like, can we reuse them in the future, right? Or is this more of an interface that's vendor specific? And then next, how easy is it to use, right? Developer experience, right, is always important, but it's especially important when it comes to the tools that you use to debug in production. Because bad tools, right, like they're annoying enough, period, but there's nothing more annoying than a bad tool when you're in the middle of an incident and stressed because you can't figure out what's going on because you're too busy fighting your tools, right? Like we should not be fighting our tools. And so this ease of use, right, can be many different things, but some of the things I tend to look for, right, is like how easy is it to set up, right? How self-service is it? And again, I think this ties back to the compatibility point from earlier. And then lastly, I said this earlier and I will say it again, platforms and tools without adoption or engineers without skills to use that platform, right, might as well be platforms that don't exist. And so the last thing we want to consider, right, is the level of support that your organization might need, right? And this can be very situational, right? For example, if your organization is new to this idea of event-driven telemetry, right, you don't want to necessarily expect them to just be able to suddenly shift towards this framework of thinking. As for me, I think I did a decent job of like evangelizing these ideas, but it's again not something that you have to do alone, right? Like we have vendors for this, and so before treading into a rabbit hole alone, right? Consider what support around the tool is available, and this isn't just referring actually to like specific support provided by the vendor you're considering, though that of course is part of it. It's also about like what developer community is around them, which transitions me to the last and final point, slash anecdote. Right, it's like, I'm biased, but it's a really exciting time for the observability space. There's so many brilliant people and communities thinking about this stuff deeply, and there's still so much to learn, right? So I think one of the things I'd like you guys to take away is like, don't try to learn this all on your own, right? Learn and contribute to the communities doing this work. Open Telemetry is an awesome community. Highly encourage you all to check them out. And this is because as much as the strength of your observability is about your team's ability to analyze telemetry data, the strength of your observability is also about our industry's collective ability to learn together and make progress together. Thank you.
Break. I have one thing announcement. Lesley, thank you so much. Oh, okay, here we go. All right. I actually had a question for you from personal experience, if you have one more second. Have you had issues with like the microservice teams going, oh, well, if you're making us conform to all this, you're going to slow our velocity down? And where that's been a problem with management, have you had to deal with that kind of issue?
Yes and no. I know, I hate that answer. I think at first, yes, that's the worry. That's why I think like making it easy is like the super important part, because like a lot of this, like they'll end up doing themselves, right? Like the idea is like
Badly.
make it easy for them to do it by like taking on the work that they would have had to otherwise. So I think like at first, yes, the way that I've approached that problem is like my teams will tend to do the like adoption of whatever tool we build for a few teams first to show like how easy it is and to build like good migration docs and things like that, or adoption docs. And that's, I think, been a really powerful way of.
So self-service and just simplify.
Yeah.
Cool. Thank you so much. All right, before we break a little bit.